Assalamu alaikum. This is me, Jannati Humayra Akhtar Himu, and my ID last three digit is 738. Today I am going to present NFA design and its real life implementation. NFA means non-deterministic finite automata, which is a core concept in the theory of computation used to recognize pattern and language. Table of content. In this presentation, we will discuss about in this topic. At first, introduction. Rest are as follow as what is an NFA, formal structure, diagram, its advantage and regular expression, and the last one is real life application, um, and the limitation of NFA, and finally the conclusion part. Let's meet our teammate Tilok Pal, Jahidul Islam Rimon, Rajiar Akhtar Srishti, and Rishadul Islam. Introduction to NFA. NFA stands for Non-Deterministic Finite Automata. It is a state machine used to recognize pattern and languages. Unlike DFA and NFA can move to multiple states for the same input and even changes state without reading any symbol using epsilon transition. Because of this feasible transition, NFA is easier to design and represent the idea of exploring multiple possibilities at the same time. If any one path leads the accept state, the input is accepted. Thank you. Now I would invite my next teammate to continue the presentation.
Hello everyone, Assalamu alaikum. I am MD Jahidul Islam Rimon, ID 24 on 5604. Now I'll explain formal structure of NFA. For define the NFA, we use some symbol like Q, summation, delta, Q naught, F. If you want to more about this symbol, we can say Q for finite set of states. That means the total state we use for design the NFA. For summation set, we use this input alphabet. For transition function, the transition function means that we move from one state to another. So who is a state and for who is input will move to on to another. uh, Q not for initial state, and F for accepting states, or we can say final state. For a better understand, we can use a example. For example, if you want to design a NFA for second position is on, then we can start Q naught, and then we will apply a self loop on it for 0 and 1. For on, we can move Q naught to Q1. For 0 and on both, we can move Q1 to Q2, and we set the Q2 as a final state, and we set the Q naught as a starting symbol. For S, here we can set a static symbol as Q naught. Here we take three state, that is Q naught, Q1, and Q2. For input, we use 0 and 1, and F or final state is our Q2. If we understand the transition table, we can say that there for Q naught for 0, we will remain the same state as its Q naught. For on, we will move Q naught and Q1. For Q1, if we use 0 as an input, we'll move Q1 to Q2, and also on, we'll move to Q1 to Q2. And we know that there the Q2 is as a final state, so we can move anywhere. That's why Q2 have no transition. That's for today. Now I will invite my next teammate for further discussion.
Adab sir, this is Tilokpal, last three digit of my D is 690. Thank you sir for giving us the opportunity to present before you. Let's talk about real life application area. Before we begin, I want to know how many times did you use search today? Maybe Google, maybe YouTube, maybe search bar on our phone. Whatever it is, we use automata without even realizing it. Yes, The concept of finite automata and regular expression might should like they belong only in theory, but in reality, these concepts are the invisible engine behind many things we use every single day. Regular expression engine powering our everyday search. Think about Google search. When we type just a few words, Google find the right result from billions of web pages in microseconds. How? Because deep inside it uses powerful pattern matching mechanism based on automata. The same happens when developers use tools like VS Code or when we run commands like grep on Linux. A tiny pattern like start with A and end with T become a fast optimized search mechanism thanks to automata. Compilers understanding the language we code. Now imagine we are writing a simple program in Java or Python. The moment we start typing, our IDE highlight the keyword, detect error and understand what we are writing. That's because the compiler analyze uses regular expression to define tokens and then convert them into NFS and DFS. Writing this automata, our code would just be meaningless text. Computer wouldn't understand anything. Network security. Protecting us from cyber threats where's something even more interesting. Automata also protect us every second. System like firewalls use pattern mechanism to identify harmful data packet. Think about our many cyber attack happens worldwide every day. Automata scan this massive traffic in real time, detecting suspicious as pattern long before we even notice. They are like digital security guard standing at every door. Text processing tool, making our typing effortless. Every time we type a message, write an email, or code in editor, something magical happens. Our device automatically highlight keyword, suggest word, and even checks our spelling. This is possible because automata scan our text a character by character, recognize patterns instantly. So we think about finite automata or regular expression. They are not just theories kept inside classroom. They are silent engine running the modern world. From the moment we wake up and checks our phone to browsing, coding, messaging, shopping, standing and safe online. Automata are everywhere, making technology faster, smarter, and safer. And next time we type something, search something, or code something, let's remember a tiny automation is working tirelessly to help us. Now let's talk about regular engine. Basically, the superheroes of text searching. Core technology. NFA is used for processing text pattern in regex engine. Inside every regex engine, there an NFA running around like a super energetic employees. It doesn't work. It jump across characters, checks patterns, and say, "Does the machine match? No. Let me try another path." It's like a multitasker on digital world, doing 10 things at once and never complaining. Searching function. Power search in Google, Linux tools and text editor. When we search something on Google, it feels like magic, right? We type a two word and boom, million of search in microsecond. Same in Linux tool like grep and in VS Code. NFA do the detective work and bring us effective uh, exactly what we need. Pattern machine, efficient machine of complex pattern. Think of a pattern machine like a finding a friend in a big crowd. Instead of shouting their name, NFS scan every face and an incredible speed. Performance. NMA enable fast or parallel exploration for large data set. NFA doesn't just check out one possibility, they explore all multiple possibility at the same time. That's exactly how NFA works. They explore every a potential match in parallel, making them super fast. So, in simple word, regular expression engine powered by NFA are just like a super fast employees of the digital world. Fast, smart, multitasker, and always ready to find the exact pattern we want. Thank you. That's all from my part. Now I would like to invite my next teammate for further discussion.
Assalamualaikum everyone. My name is Rishadul Islam. My ID's last three digits is 166. Today I am going to present text processing tool. First, we have syntax highlighting. These features use NFA based engine to identify keyword structures and important elements in text. It helps developers to use easily understand the structure of code or document. Next comes auto-completion. This tool predicts and studies suggest text based on what the user has already typed. We see this every day in search boxes, messaging apps, and text editors, where the system completes words or even full sentences. Third, here comes spell checking. This tool detects spelling mistakes and other corrections. It ensures that the final text is clean, clear, and error free. Finally, matching. Pattern matching is engines efficiently locate complex patterns in text. This is used for text validation, format checks, or even the extracting specific type of information. Together, these tools form the backbone of modern text processing systems. Next, advantages. First, simplicity in design. NFA are easy to construct compared to DFS. This means faster development time and more flexibility during the design phase. Second, flexible transitions. In an NFA, a single input can lead to multiple possible next stages. This makes the system capable of handling more complex patterns with less effort. Third comes efficient representation. For many patterns, NFS are significantly more compact than DFS. This reduces memory use and makes the system more efficient overall. Fourth, no state explosion. Unlike DFS, NFS don't require an excessive number of states during initial design. This avoids unnecessary complexity. And finally, parallel path exploration. NFS can explore multiple paths at the same time. This makes them particularly effective in tasks like pattern matching, where multiple possibilities need to be checked quickly. Overall advantages make NFA based system highly suitable for modern text processing applications. Thank you. I would like to invite my next teammate for the part.
Assalamualaikum. I am Rajiakta Srishti. Assalamualaikum. I am Rajiakta Srishti. My ID is 241150889. Today I am talking about the limitations of NFA. We are talking about lot of limitation in our presentation. First of all, backtracking overhead. First, NFA often require backtracking. This means the system may have to check multiple paths to match a pattern. Because of this, performance can slow down, especially for complex inputs. Uh, Second, state explosion. When you convert a NFA to a DFA, the number of states can increase dramatically. Sometimes it grows exponentially. This makes the harder to manage and more complex. Third, real-time processing. NFS are not ideal for real-time or time-critical systems, since they have follow many possible transition at the same time. They are not fully deterministic. So they are slower and less predictable for real-time tasks. Fourth, memory uses. Uh, NFA can consume a lot of memory, especially for larger patterns. Since they maintain multiple active states at once, the memory requirement increases. Lastly, ambiguity. NFS can struggle with ambiguous patterns because they allow multiple possible transitions. It can unclear which path should be chosen. This makes matching sometimes complicated and less efficient. So, although NFS are fixable and easy to design, this limitation makes them suitable for larger scale, real time, performance critical application. Conclusion: NFA is very useful in our computer science. It helps in things like pattern matching, regex, complexer. NFA is fixable because it can take multiple paths for the same input. Even though it has some limits, it is still an important concept that is used in many real life applications. Thank you for giving us the opportunity to present about NFA.